Welcome to Study Loop.
All right, so we have a bunch of solutes here, 3 specifically, and for each one, we want to pick which one would be the better solvent to dissolve it. So we're going to use the principle here of like dissolves like, where the likeness we're talking about is the polarity of the species, which is related to the intermolecular forces. So polar species like to be dissolved by polar species with similar intermolecular forces, meaning there's an unbalanced distribution of charge and you have dipoles. That's because the intermolecular forces of those kinds of species are going to be similar, and so it's going to be energetically favorable for them to dissolve in one another. And then nonpolar species like to be dissolved by nonpolar species. So let's see what we have. Okay, so calcium chloride, it's a metal and a nonmetal, so this is actually ionic, which is really strong dipoles to the extent that you have full separation of charge. So a polar solvent would be better for ionic. I can put here in parentheses. Okay, so we have methanol, which has an OH group. That's really polar. This is capable of hydrogen bonding. And then carbon tetrachloride, this is nonpolar. So methanol would be a better solvent. All right, our next solute. So we have 2 OH groups. Those are capable of forming hydrogen bonds, which are really strong dipoles, and that makes the compound polar. Another alcohol here, versus we have a carbon oxygen. This is also polar because oxygen pulls electrons away from the carbon. But if you have the O bonded to the H, then that's capable of hydrogen bonding. So that's more similar to the forces in our solute, and that would be a more energetically favorable process. Lastly, ammonium bromide, this, like calcium chloride, is made of a cation, a positively charged species, and an anion. So this is an ionic compound. So we want something polar. All right, we have an aromatic species here, toluene. This is very nonpolar. It's only made of carbon and hydrogen bonds. Not great. And then we have ethanol with the OH group, again, hydrogen bonding, polar. That would be better. Hope this helps.